Okay, so good afternoon. We will start with the lecture. So before we start, can anyone tell me what points we have seen up to the today's lecture? Yes, please, someone from online. Please give the answers. काय काय बघितलं आपण आतापर्यंत सांगा. Udumbar, can you tell? Swati. Okay, I will ask this side. Swati. No, whatever we have seen up till now in optical communication, you please tell. Initially, we have seen the concept of optical communication, then advantages, disadvantages, and applications. Okay, so briefly to revise, these are the things that we have covered till today. Introduction, vision, mission, syllabus, about title of course, central idea of course, all that things. Then this objective and outcomes. Then historical development of optical fiber, that point we have seen. Next, these are the previous systems which were used before the optical fibers. Then next, we have considered this optical communication, its history. You can see these developments. And then advantages of optical communication. And along with that, we have considered that disadvantages also. Okay, so those are there in the another drive. I will share them. And I have added the study material as per your requirement. At least for first chapter, I have added currently. We will see for second chapter, and if it is required, I will add. Okay. So these are the advantages, applications. Here is one new concept, that is dark fiber concept, not in syllabus, but general point that you can read for your information. And then आता इथं जे आहेत हे points, ITU recommendation. Now this ITU stands for International Telecommunication Union. So that is one standard, what we can say, the standard or final authority who is going to give the your particular thing as one some standard values. म्हणजे आता for example, एखादा तुम्ही product develop करताय, if it is related to satellite, what will be that range? If you are going to do any design, some that should be approved by some standard, and that is nothing but this ITUT. So this ITU stands for International Telecommunication Union. म्हणजे optical fiber मधल्या किंवा electronics and mostly related to the telecommunication. Whatever are the standard definitions are there, those are approved by this ITUT standard. Like IEEE. IEEE stands for Institute of Electrical and Electronics Engineers. मग आता जे आपले लँडचे वगैरे कनेक्शन्स आहेत ते IEEE स्टँडर्ड तिथं फॉलो होतात. म्हणजे those are some organizations we can say, or those are the firms which are giving final stamp for any of your design. According to these standards, the particular things are designed. मग इथे त्यांनी काय दिलेले की ह्या ITUT मध्ये G series that is related with this particular optical communication. Okay, so this is just additional slide we can say. G600 to G699. This is transmission media and optical system characteristics. आता तुम्ही LAN साठी सुद्धा IEEE चे वेगवेगळे standards असतात that you can refer. So now after this we are going to start with very important point of this chapter, that is block diagram of optical communication system. Okay, so this is the block diagram of optical communication system. Now before this we have seen the general block diagram for any communication system. कुठले तीन block असतात in the general block diagram of transmitter, receiver and channel. Okay, so that are three elements mandatory for any communication system. So now I am talking with you. I am transmitter, we are receiver, and the signal is voice, and medium it is the air that is acting as a channel. So here we have to see the optical communication system, its block diagram. Okay, now this diagram I will show, no doubt, but just to have you more clear concept, I will just show you one simple optical communication diagram. Okay, so just wait 1 minute. It is not a okay, so I will just minimize this meeting. I will show you some word file. Let us draw it by our own so that you will understand it. I will draw here. Okay, so basically this thing we have seen. आता basic, आता एखादी communication system आहे. तर first we require the, this you consider it as a transmitter. I will write here as a, so this is our transmitter. In short, I am writing. Those who are attending online, are you able to hear my voice properly? You are not responding, anyone?
Yes, ma'am.
Yes, ma'am.
Okay. So general block diagram first I will show. This is transmitter. Then this one it is the receiver. And in between that, whatever will be the block, that will be the, for any block, for any communication system block diagram, how to remember that you will understand. So stepwise I will explain. आणि हा जो middle part आहे आपला तो कुठला असणार आहे, channel, or that we also call it as a transmission medium. Now see, this one is the generalized diagram for any communication system. See here. So this is the transmitter, this is channel, and this one it is the receiver. Now in case of analog communication or digital communication, whatever we have seen, so in that this transmitter was generating which type of signal here? कुठल्या टाइपचा सिग्नल जनरेट होत होता ट्रान्समीटर मध्ये? So it was generating the signal which was in electrical form, and again it was transmitted through channel, and again it is received at the receiver. Now this is the general system, I will say. I will just write here that whatever is the first diagram, this is of any general, in short I am writing, try to understand, general communication system. But for this optical communication system, what is required? Now what will be the, this channel in case of optical fiber communication system? Channel कोण असणार आहे ऑप्टिकल कम्युनिकेशन मध्ये? कुठला मीडिया? What we are going to use as a communication channel? Glass, plastic, that is okay, but what is going to be the communication media? Fiber optic cable. So fiber optic cable, this is usually also abbreviated as fiber optic cable, FOC. मग इथं ट्रान्समीटर आहे, इथं रिसीवर. आता ट्रान्समीटर हा जनरेट करताना इलेक्ट्रिकल सिग्नल जनरेट करत नाही. ट्रान्समीटर कुठला सिग्नल जनरेट करतोय? इलेक्ट्रिकल फॉर्म मध्येच ट्रान्समीटर सिग्नल जनरेट करतोय. So the signal generated by this transmitter is in electrical form, but the electrical form signal cannot be as it is accepted by optical fiber cable. So I will explain it here. इथं कुठल्या फॉर्म मध्ये आहे ट्रान्समीटरच्या आउटपुटला सिग्नल? इलेक्ट्रिकल फॉर्म मध्ये. But that directly this electrical signal you cannot give to this optical fiber cable. काय करावं लागेल तुम्हाला? Here you have to use some device which is converting this electrical signal in the form of what? इथे इनपुट कुठल्या फॉर्म मध्ये पाहिजे? लाईट मध्ये. ह्याचा आउटपुट कुठल्या फॉर्म मध्ये आहे? That is in the form of electrical signal. So this middle stage we have to use some device which is converting this electrical signal in the form of light, and that device is called as what? Can anyone tell? Electrical signal into optical form. or electrical signal in the form of light. What that device is called as? Can anyone tell? Yes, can you tell it? Omkar? What is the device called as, which is converting the electrical signal in the form of light? काय म्हणतात त्याला? ऑप्टिकल काय? ऑप्टिकल सोर्स का डिटेक्टर? ऑप्टिकल सोर्स. शब्दावरून लक्षात ठेवा. सोर्स मीन्स व्हॉट? दॅट विल जनरेट समथिंग. आणि कशाचा सोर्स आहे तो? ऑप्टिक्सचा. म्हणजे त्याच्या आउटपुटला काय मिळणार आहे आपल्याला? लाईट. So always in the transmitter side of optical communication system, compulsory we have to use this optical source. Without the use of optical source, optical communication system design is not possible. So here we require the optical source, then that signal is converted in the form of light, then it is given to fiber optic cable. मग आपल्या जनरल कम्युनिकेशन सिस्टीम पेक्षा इथं कुठला एक ब्लॉक ऍडिशनली आला? ऑप्टिकल सोर्स. आता हा इलेक्ट्रिकल सिग्नल इथून जनरेट झालेला आहे. ऑप्टिकल सोर्स कन्वर्ट्स इट इन द फॉर्म ऑफ लाइट and again give it to the fiber optic cable. Now this all part is transmitter part. So again at the output of fiber optic cable, signal is in which form? Light. Fiber ahe. Suppose you consider this is the optical fiber. This is transmitter side. Here we have converted it in the form of light. It is passed through the fiber. Again at the receiver it is going to be in the form of first. त्याच्या एंडला येणारा कुठला असणार आहे? लाईटच्या फॉर्म मध्ये. बट दिस लाईट यू डायरेक्टली कॅनॉट गिव्ह टू द रिसिव्हर. अगेन बेसिक सिग्नल कुठल्या फॉर्म मध्ये आहे? इलेक्ट्रिकल. सो हियर अगेन यू नीड द ब्लॉक विच इज कन्वर्टिंग द what? Which is converting this light signal again in the form of what? Here light चं कशामध्ये कन्वर्जन व्हायला पाहिजे इथं? परत इलेक्ट्रिकल मध्ये. So what this device is called as, which is converting? Yes, that is called as the optical detector. So at transmitter compulsory we have to use optical source, and at receiver we have to compulsory use the optical detector. So these are the two mandatory additional blocks in the optical communication system. मग आता आपण जे इलेक्ट्रिकल मध्ये बघितलं होतं की हा ट्रान्समीटर आहे, मध्ये मॉड्युलेशन आहे, परत चॅनल, डिमॉड्युलेटर, रिसिव्हर. मग हे जे आहेत मॉड्युलेशनचे ब्लॉक ते ऍडिशनली असू शकतात ऑप्टिकल सिग्नल मध्ये सुद्धा. म्हणजे फॉर एक्झाम्पल तुम्ही AM चा सिग्नल ऑप्टिकल फायबर थ्रू पास करू शकता, तिथं परत मॉड्युलेशन लागतं. बट the basic block diagram of optical communication system consists of these 5 blocks. First you try to understand the concept so that जरी एक्झाम मध्ये तुम्हाला ऍज इट इज डायग्राम ड्रॉ करता आली नाही तरी at least if you are clear with the concept you will be able to draw somewhat diagram by your own. ट्रान्समीटर लागणार आहे, रिसिव्हर लागणार आहे, चॅनल लागणार आहे. मध्ये कुठले दोन ब्लॉक ऍड झालेत? फक्त ट्रान्समीटर मध्ये इलेक्ट्रिकलचं ऑप्टिकल साठी मध्ये कन्वर्जन करण्यासाठी पाहिजेले ऑप्टिकल सोर्स, and at the receiver again to convert back the light signal in the electrical form we need the optical detector. Okay, so this is the block diagram of optical communication system. Okay, now we will go to the in detail block diagram. Okay, so here also you can see. So otherwise I will show you just the standard diagram from book so that you will understand it more. In PPT also I will add the same diagram. Just wait 1 minute. This also. So here is the unit wise notes I have added in the study material. I don't know whether you have seen or not. बघा आता इथं पहिले पॉइंट्स आहेत. And this diagram also I can show you. These are the basic things. advantages, disadvantages, then ray theory of light. You can refer these notes. Okay. Diagram I have to show you. So in this book, at the first chapter or at the see, I was telling you about this graph. This graph it is showing the history of fiber optic cable. कुठल्या रेंज मध्ये कुठली फ्रिक्वेन्सी आपण यूज करतोय. ओके, दॅट इज शोन in this particular graph. Okay, so I want to show you basically this diagram about the optical communication system, which will clear your concept properly. See here, first A diagram is given for general communication system. काय काय त्याच्यामध्ये बघा, information source that generates the information signal which we have to transmit. Suppose आता आपला function generator आहे. So function generator acts as a information source. It is generating analog signal as well as it is generating the digital signal. Okay, so information source, then transmitter. आता इथं modulator, but modulator can be optional. आपल्याला जर रेग्युलर इलेक्ट्रिकल सिग्नल ट्रान्समिट करायचं तर फक्त मॉड्युलेटर इज नॉट मॅन्डेटरी. दॅट्स व्हॉट आय हॅव शोन इन दिस डायग्राम. ट्रान्समिटर नंतर ऑप्टिकल सोर्स. सेम हियर ऑल्सो यू विल सी जनरल ब्लॉक डायग्राम, इन्फॉर्मेशन सोर्स, ट्रान्समिटर म्हणजे मॉड्युलेटर, ट्रान्समिशन मीडियम, रिसीवर, demodulator and destination. This is diagram A, which is general communication system. आणि इथं जे आहे second diagram, that is for optical fiber communication system. Okay, you see this second diagram carefully. What is the difference? You can compare these two diagrams. First block is same, information source. नंतर electrical transmit. आता electrical transmit is nothing but जर तुम्हाला त्याचं मॉड्युलेशन करायचंय किंवा whatever is the basic signal, if you have to make some changes in the basic signal in order to make it more suitable for the transmission purpose. म्हणजे analog signal असेल तर त्याचं मॉड्युलेशन होतं, डिजिटल असेल तर तिथं एन्कोडिंग होईल, like that. Electrical transmit means what? Whatever information signal is generated through this information source in order to make it more suitable for transmission. Whatever processing you are doing on that signal, that is done in this electrical transmit. Then it is given to the optical source. म्हणजे हा जो मॉडिफाय होऊन आलेला इलेक्ट्रिकल सिग्नल आहे, that is given to this optical source. What this will do? It will convert the electrical signal in the form of light. And always you remember the input signal to the optical source should be in the form of what? इलेक्ट्रिकल. म्हणजे आता समजा आपल्याला व्हॉइस ट्रान्समिट करायचा आहे तर तुम्ही डायरेक्टली व्हॉइस देऊ शकत नाही ऑप्टिकल सोर्सला. यू हॅव टू फर्स्ट कन्वर्ट दॅट व्हॉइस इन द फॉर्म ऑफ इलेक्ट्रिकल सिग्नल अँड देन दॅट यू हॅव टू गिव्ह टू द ऑप्टिकल सोर्स. लक्षात ठेवा, यू कॅन राईट डाऊन इट समवेअर. ऑप्टिकल सोर्स कन्वर्ट्स इलेक्ट्रिकल सिग्नल इन द फॉर्म ऑफ लाईट. त्यामुळे तुम्हाला जो सिग्नल ट्रान्समिट करायचा आहे तो जर इलेक्ट्रिकल फॉर्म मध्ये नसेल तर व्हॉट फर्स्ट यू नीड टू डू? Convert that signal in the form of electrical signal. Okay, so electrical transmit, optical source, then optical source output कुठे जाईल? Optical fiber cable. Then at the output of optical fiber cable again the signal is in the form of light. So that is given to the optical detector. That optical detector will convert the light in the form of electrical signal and then again given to electrical receiver. म्हणजे रिसीवर म्हणजे काय असणार आहे? ट्रान्समीटर मध्ये जर फॉर एक्झाम्पल मॉड्युलेशन केलं असेल तर इथं काय होईल? डिमॉड्युलेशन. whatever here you are adding that will be subtracted at this electrical receiver and then the last block it is the destination. So this is the block diagram of optical communication system. हे जरी इलेक्ट्रिकल ट्रान्समिट, इलेक्ट्रिकल रिसीव हे जरी ऍड करायचं तुमचं राहिलं तरी ऍटलिस्ट ही जी डायग्राम मी तुम्हाला दाखवली हे 5 ब्लॉक तर कंपल्सरी यायला पाहिजे. ट्रान्समीटर, रिसीव्हर, ऑप्टिकल सोर्स, ऑप्टिकल डिटेक्टर आणि फायबर ऑप्टिक केबल. Okay, so are you clear with the basic block diagram of optical communication system? See, this diagram is very important from your theory point of view as well as your practical point of view. Practical मध्ये आपल्याला different practicals we have to see based on this transmission. म्हणजे how to transmit the analog signal, how to transmit the digital signal, again how to transmit the AM signal, FM signal, PWM signal through fiber optic cable. That also you have to see. Okay, so this side, is it clear? Online students, are you attending or not? Give
Yes,
some
clear.
answers. Okay, I thought some are attending online while you are in the NSS camp or what. Please pay attention. So this is about the block diagram of optical communication system. Now in theory what you have to write? Okay, you just draw this optical communication diagram. Block kadate, that is important. Just draw it. Take 2 minutes and draw it. Block diagram of optical communication system, because this is compulsory asked in the exam. Please draw it. Draw this diagram B. Completed? Yes, Pranav.
No, ma'am.
Draw that diagram B. This part is related with transmitter. This part is related with the receiver, and this one it is the channel part. Okay, and in its explanation, what you have to write, that already I have given you the notes. Now everything that I will not dictate, but at least the main things whatever are there, that you can note down that things. What is the function? Like you tell me once this diagram is over. Now I hope everyone has completed this. So in exam what you have to write? First you have to draw this diagram. Then step by step, block wise you explain what is function of each block. For example, information source. What is the function of information source now? काय generate करेल information source? It is generating the signal which we have to transmit. But here I am considering the information source is generating the electrical signal. So let it can be in the analog form or in the digital form. So information source generates the signal which we have to transmit, and it can be in analog form or in the digital form. Then electrical transmit. Electrical transmit, that block is processing on the basic signal in order to make it more suitable for transmission. म्हणजे फॉर एक्झाम्पल इथं मॉड्युलेशन असू शकतं. मॉड्युलेशन मुळे काय होतं, बेसिक सिग्नलची स्ट्रेंथ तिथं इन्क्रीज होते and that is more suitable for the transmission purpose. This is electrical transmit. Then optical source. What that optical source will do? It will convert the electrical signal in the form of light and then it is given to the fiber optic cable. What is the function of fiber optic cable? It carries the information signal given to it and it gives at the output side or it gives at the receiver side. Then this optical detector. So optical detector will convert the light signal in the form of again electrical signal. Then electrical receive means opposite. इथं काय केलं असेल तुम्ही, त्याचं इथं रिकव्हरी होते त्या मेन सिग्नलची. So based on this transmitter part, the reverse process will be applied in the electrical receiver and this last one destination, that is the final signal at the receiver. Okay, so that you have to write in the exam. Okay, you just write down in one line, I will tell, not more than that. But these are the basic things and now you have to face the online, probably you have to face the offline exam. That's why that habit should be developed. That's why I'm telling you. Write down, information source generates the information signal. Information source generates the information signal which we have to transmit full stop. It can be in analog or digital form. It can be in analog or digital form. Full stop. Next, electrical transmit. Next block है तो electrical transmit is the block. Electrical transmit is the block which process on the basic signal. Which process on the basic signal and makes it more suitable for transmission. On basic signal and makes it more suitable for transmission. More suitable for transmission. Next line you write optical source. Optical source. In that you write optical source. In that you write it converts the electrical signal in the form of light. Electrical signal in the form of light. Full stop. Next, OFC, that is optical fiber cable. Optical fiber cable carries the light information signal full stop Next line. Optical detector converts the light signal in the form of electrical signal, full stop. Next, electrical receive it recovers the original signal. It recovers the original signal from the received signal and gives it to final destination. आता इथे बुक मध्ये अजून ऍडिशनल इन्फॉर्मेशन दिलेले आहे की कुठले कुठले डिव्हाइस आपण ऑप्टिकल सोर्स म्हणून वापरू शकतो. It can be LED or it can be laser. If you consider this optical detector, those we are using the photodiodes. Means PN photodiode can be there, PIN photodiode. बघा आता इथे दिलेले आहे. PN, PIN or avalanche photodiode, or in some of the cases we are using phototransistors as well as photoconductive materials as optical detector. Okay, so this is the block diagram of optical communication system. Okay, so I hope you are clear with that. So here is the additional diagram for digital optical link. So this you need not to draw in the exam. Just this second diagram is only sufficient. Okay, so I hope you are clear with the block diagram of optical communication system. Is it clear, Omkar? Yes. Omkar is there? Audumbar? Aishwarya?
Yes, ma'am, clear.
Okay. Now the next point we will see. Wait 1 minute. Here also in PPT if you see, concept it is same. हे बघा हा इलेक्ट्रिकल इनपुट सिग्नल आहे, ड्राइव्ह सर्किट म्हणजे त्याला इट इज सेम ॲज इलेक्ट्रिकल ट्रान्समिट. देन लाईट सोर्स, देन गिवन टू फायबर. फायबरच्या पुढे स्प्लाइस असू शकतो. स्प्लाइस म्हणजे काय, 2-3 फायबर. आता इथे बघा हा एक फायबर आहे, दिस इज सेकंड फायबर. टू कनेक्ट दॅट two fibers you have used here optical splice, that is nothing but optical joint. Then here optical receiver, then repeater, electronics, this is optical transmitter. So all that things are same, but this is bit complicated, that's why you don't right now you don't look into that. Whatever is there in the book, that same I will actually I have copied it, but that is in the pen drive. So I will modify that notes only I have uploaded in your study material. Okay, so this is about the block diagram of optical communication system, which is the compulsory question asked in the exam. I hope you are clear with this. Now we have to start with the ray theory of light. Okay, so you please pay attention for whatever points here after I am going to explain, because this ray theory of light is very important point in overall optical communication syllabus. कारण ऑप्टिकल फायबर मधले जे लॉसेस आहेत किंवा ऑप्टिकल फायबरचे जे टाइप्स आहेत, ऑप्टिकल सोर्सेस, ऑप्टिकल डिटेक्टर, for understanding all the next point, first you have to understand how the optical fiber is working, and it is basically working on two theories. First is mode theory of light and another it is the ray theory of light. I will just show you the syllabus. Already we have seen इट्स हिअर ना. बघा आता इथं जर तुम्ही सिलेबस मध्ये पाहिलं ओसीच्या तर दोन थेरी आहेत इथं, रे थेरी अँड मोड theory. How the optical fiber passes the light through that. To understand that there are two approaches, ray theory of light and mode theory of light. Right now we are considering first the ray theory of light. कारण ह्या दोन approaches जर आपण comparison केलं तर mostly सगळीकडे ray theory of light it is used to transmit the information through the optical fiber. मग आता फायबर मध्ये आपण बघितलं होतं बेसिकली आय हॅड टोल्ड यू दॅट स्ट्रक्चर ऑफ फायबर यू कॅन कन्सिडर सेम ॲज दिस ऑफ दिस पेन. सेंटरला काय येतं कोर आहे. कोर इट इज सराउंडेड बाय द क्लॅडिंग. सो बट युअर इंक इज कमिंग थ्रू रिफिल ओनली. outer side part it is just for the protection. Similar you can consider the structure for this optical fiber cable also. At center it is having core and that core it is surrounded by the cladding. So here you can see I have shown you various pictures also for this optical fiber cable. बघा तुम्ही आधी front view, back side view that you first understand. This is side view. Here if you see बघा आता इथं सेंटरला काय कोर, इथं काय असणार आहे मध्ये हा axis and again core and that is surrounded by cladding. That's why side view तुम्हाला असं दिसतो. हा मध्ये axis आहे core area, then this side it is cladding, this side it is cladding. Here also this diagram if you see, this is the white part जो दाखवला आहे hollow, that is the core part and this blue part stands for the cladding. So this is the another view we can say. Here also it is more clear. See this inner part, this is the core. हा जो आहे हा section पूर्ण हा from this all this part is related to core and upper side and below side both it is covered by the cladding. That's why here ही जी इथं डायमीटर दाखवलेला आहे 6 ते 10 मायक्रोमीटर हा कशाचा आहे कोरचा आहे आणि क्लॅडिंगचा किती दाखवला इथं डायमीटर 125 मायक्रोमीटर. ओके लाईक दॅट. कोरचा रिफ्रॅक्टिव्ह इंडेक्स हा N1 ने रिप्रेझेंट केला जातो. क्लॅडिंगचा रिफ्रॅक्टिव्ह इंडेक्स हा N2 ने रिप्रेझेंट केला जातो. यू बेसिक थिंग्स यू रिमेंबर रिलेटेड टू ऑप्टिकल फायबर. कारण तिथे N1 N2 अशा नोटेशन वापरलेले आहेत रे थिअरी ऑफ लाइट मध्ये. You have to understand that N1 stands for refractive index of core and N2 stands for refractive index of cladding. Because in ray theory of light, whatever is the working किंवा लाईट जी प्रोपॅगेट होते त्याच्यासाठी कुठले पॅरामीटर मेन आहेत रिफ्रॅक्टिव्ह इंडेक्स. जसं आपण बघितलं की रिफ्रॅक्टिव्ह इंडेक्स हा कसा आपण डिफाइन करतो एखाद्या मटेरियलचा speed of light in air divided by speed of light in the particular media. So when light ray is traveling from this class into another class, its refractive index is different. The refractive index of the another object it is different. आणि हा जी मधली वॉल आहे ह्याला आपण काय म्हणू शकतो कोर क्लॅडिंग इंटरफेस. म्हणजे इथं बघा तुम्ही नाउ दिस विल बी द कोर पार्ट. This one. That's why I said that some visualization is important for this subject. This is core. आता हा लाईट रे इथं आला तर हा इथून क्लॅडिंग मध्ये जाईल. जर त्याला आपण काहीच मेकॅनिझम अप्लाय नाही केला तर काय होईल तो सी फॉर एक्झाम्पल इफ दिस इज लाईट कमिंग हा कोर आहे असं कन्सिडर करा. And that light ray comes and it strikes on the wall. So what we want, again that light has to reflect. It has to come back in the class only. तो तिकडे रिफ्रॅक्ट व्हायला नाही पाहिजे. मग त्याच्यासाठी 3 केसेस आपल्याला रे थिअरी ऑफ लाईट मध्ये बघायचे. सो यू फर्स्ट अंडरस्टँड दिस 3 बेसिक टर्म्स N1 for refractive index of core, N2 for refractive index of cladding. आणि हे जे ऑप्टिकल फायबरचं बेसिक वर्किंग प्रिन्सिपल आहे that is totally dependent on total internal reflection. You can write down that line. The basic working principle of optical fiber is total internal reflection. Total internal reflection. In bracket you can write capital TIR. This question is also asked in the MCQ. Basic working principle काय ऑप्टिकल फायबरचं? टोटल इंटरनल रिफ्लेक्शन. म्हणजे कोर मध्ये जी लाईट आहे ती कोर क्लॅडिंग इंटरफेस वरती इन्सिडेंट झाल्यानंतर क्लॅडिंग मध्ये एंटर होते का? नाही. परत ती कुठे होते? रिफ्लेक्ट कोर मध्येच होते. I will show you some next diagrams so that you will understand that point. बघा आता इथं सुद्धा this pink color light it is shown, so it is in core only, it is not propagating into the clad. बघा आता इथं हा लाईट रे इथून इथं ट्रान्समिट होतो. इथे इन्सिडेंट झाला. हा काय झाला? हा मधला पार्ट कोर आहे, हा क्लॅडिंग आहे. ही जी लाईन आहे इथली दिस लाईन दॅट इज कोर क्लॅडिंग इंटरफेस आहे ना तो. दिस लाईन which I am highlighting that is core cladding interface. मग इथून लाईट रे आला की ती परत कोर मध्येच रिफ्लेक्ट होते. इट इज नॉट एंटरिंग इनटू द cladding. Again here next it travels, comes and it strikes here again at the core cladding interface. आता core cladding interface वरती पण आहे, खालच्या साईडला पण आहे. But again here also it is reflected and sent back again in the core. म्हणजे ही अशी चालू राहते त्याची मूवमेंट. सपोज दिस इज द ऑप्टिकल फायबर. इथं काय होईल? इथं स्ट्राइक होईल, परत माघारी येईल, परत स्ट्राइक होणार. सो दिस इज द टोटल इंटरनल रिफ्लेक्शन थ्रू विच द लाइट इज प्रोपॅगेटिंग इन द ऑप्टिकल फायबर. टोटल इंटरनल रिफ्लेक्शन होण्यासाठी काय कंडिशन आहेत मॅन्डेटरी दॅट वी हॅव टू सी. आता जर तुम्ही काहीच मेकॅनिझम अप्लाय केलं नाही तर रिफ्लेक्शन होत नाही. नॅचरल टेंडन्सी काय असते लाईटची? इट गेट्स रिफ्रॅक्टेड. जेव्हा एका मीडियम मधून दुसऱ्या मीडियम मध्ये लाईट एंटर होते तेव्हा ऍज पर द नॅचरल प्रॉपर्टी ऑफ लाईट इट गेट्स रिफ्रॅक्टेड. बट बाय अप्लाइंग सम मेकॅनिझम वी आर फोर्सिंग इट टू गेट टोटल इंटरनली रिफ्लेक्टेड in order to make it compulsory to travel only through core or cladding. Core. We are making it to compulsory travel through the core and not allowing it to enter into the cladding. त्याच्यासाठी काय कंडिशन्स आहेत ते आपल्याला रे थिअरी ऑफ लाईट मध्ये बघायचे. Now the first basic condition for total internal reflection is, which you can see here. So the basic, just a minute, I will slide show. So the basic property is, or basic concept here is, the refractive index of core should be greater than refractive index of cladding. Okay, so there was one diagram, no? See here. Bagaita. N1 hai, N2 hai. So what is the basic condition? N1 should be greater than N2. First thing you understand, for ray theory of light to work the optical fiber with total internal reflection, the very first basic condition is N1 should be greater than N2. Means refractive index of core should be always greater than refractive index of cladding. And these are slightly different. असं नाही की कोरचा 1.4 आहे आणि क्लॅडिंगचा 1.7 आहे. They are very slightly different. For example, N1 will be 1.47, N2 will be 1.46 किंवा 0.02 डेसिमल वगैरे त्याच्यामध्ये डिफरन्स असतो. बट that difference is there. So first condition for ray theory of light is N1 should be greater than N2. Why that is applicable, that we will see. But you first understand N1 should be greater than N2. आता काय होतं बघा, आपण रे थेरी ऑफ लाईट पॉइंट आपण स्टडी करूया. सो फॉर रे थेरी ऑफ लाईट, फर्स्ट we will see this basic three concepts. बघा आता काय होतं, when light waves strikes on object, some of the waves are absorbed by the object, some are reflected and some are passed through it. इथं दाखवलंय बघा, आता इथं लाईट रे आहेत. त्या लाईट रे पैकी काही लाईट रे हे त्या डिव्हाइस मध्ये, the device itself it is absorbing it. This is first case here, absorption. Then second case मध्ये काय झालेलं आहे सांगा मला, आणि थर्ड केस मध्ये काय झालेलं आहे. ह्या केस मध्ये काय झालंय, पास झाली आहे का रिफ्लेक्ट झाली आहे का रिफ्रॅक्ट झाली आहे, रिफ्रॅक्टिव्ह. इथं ऍब्सॉर्ब झाले, इथं रिफ्रॅक्शन झाले त्याचं, आणि इथं काय झाले परत तिथंच परत रिफ्लेक्ट झाले. सो हियर इट इज reflected. So that three phenomena are very nicely shown in this diagram. So here the light rays are absorbed by the device. Here the light rays are what we can say, they are passing through the device, and here those are reflected from the device. मग हे तीन cases आहेत when light passes through any, or when light is strike on any device. Either it is absorbed, or it is passed, or it is reflected. Understood this first diagram? Then in ray theory of light, these three cases we have to see. First case आहे general refraction case. First case is refraction. Second case is, see here, second case is critical angle case, and third case it is the total internal reflection. या तीन पॉइंट मध्ये रे थेरी ऑफ लाईटचं एक्सप्लेनेशन आपल्याला लिहायचंय. ओके, यू जस्ट राईट डाउन दॅट मेन थिंग which will be helpful to understand the main concept. In ray theory of light, in ray theory of light, we have to study three cases. In ray theory of light, don't see there, I'm just dictating general points. In ray theory of light, we have to study three cases. Three cases. First, refraction of light. Refraction of light. Second, critical angle case. Critical angle case, and third is total internal reflection. Total internal reflection. Okay, now we will see the first case, that is refraction. Refraction case simple hai. In this diagram, this N1 it is shown, means this is core, and this is the N2. So N1 is having high density because core is having more refractive index, and this N2 it is low density because N2 is having less refractive index. आता इथं काय होतंय बघा, हा कोर आहे, हा क्लॅडिंग आहे, हा रे 1 आला, this ray 1 is incident on this line. This line it is called as the core cladding interface. बघा इकडं कोर आहे, इकडं क्लॅडिंग आहे, मध्ये काय आहे त्याच्या कोर क्लॅडिंग इंटरफेस. मग पहिली रिफ्रॅक्शनची केस बघतो आपण आता. मग रिफ्रॅक्शन मध्ये काय, हा एक फर्स्ट लाईट रे दाखवलाय पर्पल कलरनी, So this light ray it is coming. हा इथं कोर क्लॅडिंग इंटरफेस वरती स्ट्राईक होतो आणि काय होतंय त्याचा परत तो N2 मध्ये जातो. सो इट इज गेटिंग रिफ्रॅक्टेड. बघा आता हा पहिला बघा, दिस पिंक और पर्पल वॉट एव्हर इज द कलर. दिस पिंक रे इट इज कमिंग हियर and it is refracted. So it is going into the cladding. It is coming. It is first in core, striking on core cladding interface and then entering into the cladding. मग ही कुठली प्रोसेस झाली? रिफ्रॅक्शन. सेकंड रे सुद्धा तसाच आहे हा ग्रीन कलरचा. इट इज इन कोर, इथून ट्रॅव्हल होत हा काय झाला कोर क्लॅडिंग इंटरफेस वरती इन्सिडेंट झाला आणि तिथून परत तो इकडं. ही सेकंड केस थोडी वेगळी आपण बघूया. पण काय होईल बघा, तर हा रे रिफ्रॅक्ट होतो. मग आता इथं हे दोन अँगल महत्वाचे. दिस थिटा आय इज अँगल ऑफ इन्सिडन्स अँड दिस थिटा आर इज अँगल ऑफ रिफ्रॅक्शन. अँगल ऑफ इन्सिडन्स कसा मेजर करायचा? हा जो रे आहे, दिस रे जो तो जिथं कोर क्लॅडिंग इंटरफेसला इन्सिडेंट झालाय तो पॉइंट, अँड फ्रॉम दॅट पॉइंट यू हॅव टू ड्रॉ वन नॉर्मल. त्याला 90 डिग्री परपेंडिक्युलर मध्ये एक लाईन ड्रॉ करायची. म्हणजे हा इन्सिडेंट रे हा इथं जिथं स्ट्राईक झालाय तिथून एक 90 डिग्री मध्ये इथं लाईन ड्रॉ करायची. मग ह्या दोन मधला अँगल जो आहे दॅट इज युअर अँगल ऑफ इन्सिडेंस. अँगल ऑफ रिफ्रॅक्शन कसं मेजर करायचा? दिस रे and angle between this perpendicular line, ह्या दोन मधला जो अँगल आहे दॅट इज अँगल ऑफ रिफ्रॅक्शन. आणि as per the Snell's law, n1 sin theta 1 is equal to n1 sin theta n2 sin theta 2. म्हणजे काय स्नेल्स लॉ नुसार n1 आणि n2 ह्याच्या व्हॅल्यू वरून थीटा आय आणि थीटा आर ची व्हॅल्यू डिसाइड होते. सो इफ n1 इज ग्रेटर दॅन n2 देन थीटा आय इज लेस दॅन थीटा आर. ते काय रिलेशन आहे आणि त्याच्यावरून कसं तिथं रिफ्लेक्शन आपण पुढे बघतो, दॅट वी विल सी इन द नेक्स्ट लेक्चर. बट राईट नाउ इन दिस डायग्राम व्हॉट यू कॅन अंडरस्टँड, हा इथे इन्सिडेंट झालाय, इथं आपण अँगल ऑफ इन्सिडन्स मेजर केलाय. हिअर वी हॅव मेजर्ड द अँगल ऑफ रिफ्रॅक्शन. आता इथं हा जर 30 n1 आणि n2 मध्ये काय रिलेशन आहे? n1 इज ग्रेटर दॅन n2 and as per the Snell's law this is the equation. n1 sin theta 1 is equal to theta I is equal to n2 sin theta r. So as n1 is greater than n2, this theta I is less than theta r. म्हणजे हा जर 30 असेल तर हा 40 असेल, हा जर 40 असेल तर हा 50 असेल. दॅट इज द रिलेशन अँड दॅट इज द फर्स्ट केस रिफ्रॅक्शन. मग हा अँगल जर मी असं वाढवत गेले तर काय होईल? इकडचा अँगल सुद्धा काय होईल? वाढत जाईल. मग एक कंडिशन अशी येते की हा अँगल ऑफ रिफ्रॅक्शन जो आहे हा 90 डिग्री होतो. That is the second case, critical angle, that we will see in the next lecture because that is important point. You understood the refraction case, first case? Okay. So those who are present online, please type your numbers in the chat box for attendance. Time is over, no? And after typing your number in the chat box, you can leave the meeting online.